This unit is all about solving algebraic expressions. Now, a simple way to say what an algebraic expression or equation is simply solving for an unknown variable. For example, let's say I know some number, which I'm going to represent by x, plus 5 equals 15. Now, we don't need to really do anything to take a guess at what that x could be. We know it's going to be 10. So 10 plus 5 equals 15. So some of these expressions are pretty easy to figure out just by taking a guess at it. We're going to be looking at a few harder ones where we got to follow a few simple steps in order to solve for x. So whenever you have an equation, it doesn't matter what you have. It could be x plus 5 all over 2 equals 15. Whenever you have something like this, we ultimately want to end up with the letter all by itself on one side and the numbers all on the other side. So if the letter is E, you can use S, you can use M. It doesn't really matter what letter we use. Sometimes you'll see X and sometimes you'll see other letters. So we always want to figure out how are we going to get this letter all by itself on one side and all of the numbers on the other side. So we're going to do a few examples with that, and we're going to follow two basic steps in order to do it. So here's one of the sheets that was included here. It's called Infinite Algebra 1, and what we're going to try to do, this is starting off with a very simple equation. So I'm going to zoom in a little bit, just to make it a little bit easier to see, this particular problem. Let me see, view, zoom, let's go 300%, so it's a little easier. There. So here's what we have. We have 26 equals 8 plus v, and in this case they didn't use x, they used the letter v. Now we know we want to have v all by himself in the end. So what is it we want to move? Well, this 8 is going to have to move to the other side. So when we move him over to the other side, a funny thing happens with the 8. Since we know it's a positive 8, because there's nothing in front of it, there's no minus in front of it, when we move this positive 8 to the other side, we're going to still have 26, but we're going to end up with this positive 8 becoming take away 8. And don't forget, we still have this positive v left on this side, and I'm just going to leave it as v. Now when we go 26 take away 8, the final answer will be 18 for v. So that will be our final answer. So in ones like this, there's only one step to do. All you have to do is move this guy over to the other side and change the sign from a positive to a negative. Looking at a one like this, where the p or the letter is on this side, of course, we're not going to move the p over here. We're going to move the number. So this positive 3 goes over to this side and becomes negative 3. So all we're left with now is p on one side, and of course 8 take away the 3 on the other. So the answer to p will be 8 take away 3, which is 5. Now we can easily test out to see if we're right by simply putting 5 back into the original equation for p. So if I go back here and I look at the original equation, which was 3 plus p equals 8. So remember, our answer was 5. So 3 plus, let's put 5 in for p, and we can put it in brackets if you want. So 3 plus 5 does equal 8. So we have 8 on each side, so we know our answer is correct. So that's if you're asked to figure out, and of course, let me move this guy over. That's if you're asked to validate or check your answer. All you got to do is take your answer, in this case it's 5, and plug it into your letter. Be careful when you get to negatives here. Sometimes when you put a number to the other side, the negative becomes positive, of course. So in this case, the minus 15, when we move it to the other side to separate it from the positive n, we're left with n on one side. And this minus 15 Don't forget the minus 9 still there. This minus 15 becomes positive 15. Now the easiest way to think of when you're doing addition of negative numbers and a positive number, you can take out your calculator in this case, and on most calculators you will find a positive and negative sign there. So if I want a negative 9, all I have to do is punch in 9 and then press the positive negative one, and that automatically changes it to negative 9. And then to add 15, just go plus 15. And our answer, of course, for this one would be 6. So in this case, n will equal 6. So that's if you have a calculator that has the plus and minus on it. If you don't, just think about it this way. If you have a negative 9 on the thermometer, and I could draw a lovely thermometer, and if we're all the way up to negative 9, of course, we go up a degree, it's negative 8. If we go up another degree, it's negative 7. So if we go up 15 degrees, we're going to have to jump 1, 2, 3, 15 times. We're going to have to do that 15 times. So you could draw a number line and think of it like a thermometer, and if you're adding, you go this way. If you're taking away, you go the other way. And of course, adding a negative, if you have one, is the same thing as taking away. So in this case, the 15 moves over here and becomes negative 15. The plus 4 here moves over and becomes negative 4. The negative 9 moves over and becomes positive 9. The negative 15 moves over and becomes positive 15. And so on. So in just about every one, whenever you have it and you're trying to figure it out, all you have to do is move the one that's not attached to P. There's nothing attached to P, just move it over to the other side and change the sign to a positive. And you'll get your answer. Here's another one. It's a single step one, but it's not plus or minus. You'll notice that it's a fraction. So in any fractions written like that, what this fraction really means is divided by. And to find what the opposite of divided by is, you just have to think of multiply. So if you have v over 8, and you're dividing by 8, and you got to times it by 8, or do the opposite, that will cancel it out for you. But don't forget, whenever you do it to one side, you must do it to the other side. So we have v left all by himself, and 2 times 8, which is 16. So we just solved for v. v will equal 16. So I could show you that one in another one here. There we go. So we got 16 equals k over 11. I think I'll put that one on another page. So 16 equals k over 11. So we want to get rid of everything on this side except for the k. Well, since this means divided by, a fraction is divided by, we're going to do the opposite, and we're going to multiply by 11. That will cancel out, of course, the 11s, because 11 over 11 is going to equal 1. Anytime you have a fraction that is, say, even 7 over 7, that equals 1. 20 over 20 equals 1. So don't forget, though, when you times one side by 11, you must do the exact same thing to the other side. So I'm going to have the times 16 by 11 as well. So I'm going to take my calculator, move him over here, and of course then I'm going to go 11 times 16, and my answer, of course, is 176. So my answer to this math problem, just by using the calculator, will be 176 left on one side, and the other side is just k, so k equals 176. It doesn't matter which side you put the k on or which side you put the other one on. Sometimes you'll see it written both ways. Looking at this one, this is not a divided by. There's no divided by underneath that. There's no fraction. So whenever you see just the numbers touching the letter, that really means multiply. And of course, we're going to do the opposite. So when you got negative 15 times x, we're going to go and divide it by negative 15, like that. That will cancel out the negative 15. But don't forget, what you do to one side, you must do to the other. So I'm going to divide 0 by negative 15, and it doesn't really matter. When we solve that, 0 divided by anything is still going to be 0. So x will equal 0 in this case. Looking at number 19, there's a negative 7 in front of n, so you've got to divide it because negative 7 is times n. So you must divide it by negative 7, like that. And of course, you do it to one side, you cancel out the minus 7. You must do the exact same thing to the other side. So we're left with just n on one side. And 21 divided by 7 is 3, and you can use your calculator for that. But don't forget, it's a positive 21 divided by a negative 7. So a positive divided by a negative is always a negative. Okay? The only way you can get a positive out of a negative is if both of them were negative, which they're not, so we're not going to put it there. So in this one here, since that's 14 times k, we're going to divide it by 14 on each side. Moving over here, this is negative 11x, so we're going to divide it by negative 11 in order to cancel it out, and then we're going to divide this by negative 11 on this side. So a negative divided by negative is a positive. So we know our answer is going to be positive. So x is all by himself now. 143 divided by 11, if I were to take my calculator. So 143 divided by 11. And you notice I didn't put in the negatives when I did it, because I know a negative divided by a negative is a positive. So I don't need to worry about my negatives. But my answer does turn out to be 13. So if we put x back in there, if we put 13 times negative 11, we should get negative 143. So we could always check our answer. So this one here is divided by 18, so we're going to times it by 18 to cancel out this side. Of course, you must times this minus 5 by 18 to cancel out, or sorry, to get your answer on that side. So it's pretty much the same thing all the time. You're either going to have the shift, if it's a takeaway or plus, you're going to have to shift it over to this side and change the sign. If it's a divided by or a multiply, you're going to have to do the opposite and times it by 7, or times it by a number, or in some cases you'll have to divide it by a number like we did up here. Alright, so now that we know how to do the shifting of numbers, and we also know how to multiply the numbers, sometimes you might get two-step equations, and these are usually the ones that are worth the most on a test. In these two steps, you just got to do one step at a time. It's no big deal, no harder. It's just you got to remember which step to do first. Okay? And in this case, we always move what's not connected to the letter. So this a over 4, we can't just take the a off and move him over here because he's part of a fraction. So we're going to keep him there, and we always move the plus or the minus first. So I'm going to take this plus 2 and shift him over to this side. So I've still got a over 4 left on the right-hand side. On the other side, since I've moved my positive 2 over here, the sign changes to a negative 2. So 6 take away 2 is 4. And we've still got that a over 4 left. Now, the easiest way to get rid of a divided by 4 that's down here, because that's the only thing left, the divided by 4, is to times it by 4 to cancel it out. And of course, if you times one side by something, you must do the exact same thing to the other side. So a's all by himself on one side. And of course, 4 times 4 will give you 16 on the other. So a must be 16 for this equation to be true. Looking down here at this one, and maybe I'll do him on a separate page again. 9x take away 7. So 9x take away 7 equals, and just to double check, 9x take away 7 equals negative 7. So remember, the first step always is to deal with the thing that's not connected to the x first. In this case, it's the minus, or to take away 7. So I'm going to shift him over to the other side, and he's going to become plus 7 because he switches signs. So we're left with 9x all by himself equals negative 7 still there, and we've also brought over a plus 7. All of a sudden, negative 7 plus a 7, they cancel each other out to give you 0. Because if you have a negative 7 degrees and you add 7 degrees, you're back to 0 degrees. And of course, 9x is still here. And to get rid of this 9 times x, we must divide it by x. And of course, we know 0 divided by anything is still going to be 0. So x will be 0 in this case. And that makes sense, because if you put 0 back into x up here, 0 times 9 is still 0. So that cancels it out. And we're left with just negative 7 on this side, which is what we've got on the other side. Okay, in this one here, it looks a little harder, but it's not really. The first thing we deal with is the plus or minus. So we'll take the minus 5 and bring him over here. So negative 5 now becomes a positive 5, because we shifted them. So negative 4 is still there, plus 5 equals, and remember this is still on that side, r over 20. So negative 4 plus 5, if you punch that into your calculator, is positive 1. And that equals r over 20. The only way to get rid of that divided by 20 now is to do the opposite, which is times it by 20. That will cancel it out. And of course, 1 times 20 is 20. So r will equal 20. Now, I'm going to take this one, v plus 9 over 3 equals 8. And I'm going to do that one, because that one's a little bit trickier. So v plus 9 over 3 equals 8. Just to double check, make sure I wrote that down correctly. V plus 9 over 3 equals 8. So again, you would almost think you got to move this plus 9 over here. But the problem is, this v plus 9 is part of this whole fraction. Okay, so it's like having it in brackets. Okay? So how do we get rid of the divided by 3 first of all? And the easiest way to get rid of the divided by 3 is to times each side by 3. Of course, that will cancel out the 3, and we'll times this by 3 on this side. And we're left with v plus 9 on one side. 8 times 3, if you work it out on your calculator, will give you 24. Now it looks like one of those one-step problems that we were doing earlier. So we take the plus 9, bring them over to the other side and shift them, and it becomes negative 9. So v's all by himself. 24 take away 9 will leave us Well, you take away 10 and it'll be 14. So add one more and it'll be 15 for our answer. So remember, anything in brackets needs to stay together. You still times it by whatever you need to times it by to get rid of the divided on the bottom. Okay, so let's try another one. And I think I'll try this one that already has a 1 here. So this one here is 2 and then bracket n plus 5. Now you could go ahead and work it all out, but there's really no need. All you need to think about is, how do I get rid of this 2 times all this stuff on that side? And the easiest way is to just divide it by 2, and that'll cancel out that. But if you do it to this side of the equation, you must divide the other side by 2. So we're left with n plus 5 equals, well, 2 divided by 2 is 1. And a negative divided by positive is a negative. So now all we have to do is shift this plus 5 over to the other side. And it becomes negative 5. That gets rid of it. Now we're left with n equals negative 1, take away 5 more, is going to be negative 6. And that will be our answer for that one. So in these two-step problems, you always start with the plus or minus first and shift him over. And then you've got to times it by a number, or sometimes you got to divide it by a number, depending upon what the opposite is. So as you can see, all of the problems on the example sheets are pretty much the same. You shift them over, and then, of course, you're going to times it by 4 to cancel out the divided by 4. If there's brackets, well, what's in front of the bracket? This is 12, or negative 12, times all this. So we're going to go divided by negative 12, and that'll cancel that. And of course, then it'll be much simpler to solve. Be careful with your negative signs. Okay? You must shift this over first, and it becomes positive. And then you've got to divide by negative 9 to get rid of the negative 9 times. So don't forget to do not just the 9 times, but the negative that's in front of the 9 as well. And the last one over here, you got to divide it by 10 to get rid of the 10 in front, but don't forget to do it to both sides, and watch your negatives when you're doing this one, and it should work out for you nice and easy, just like the rest of them. You might be given sometimes the value of x, and you might be asked to plug it back into your equation. Should be easy. Just take 2, and wherever your letter is, doesn't have to be x, just simply put 2, or whatever you're given, into it, and solve it like you always do. So 2 times 5 is 10, plus 6 more is 16. So the answer when you put x in there will be 16. When you're looking at this one here, we could use y. Usually we stick to x's and y's in math. Put 3 in for y. And of course, 4 times 3 is 12. Take away 8 will give you 4 for your answer. All the answers are given to you anyway, so this is just a practice that you can go ahead and work on. Now, why do you need to know how to plug in certain numbers and solve and get an answer? Because when you start the graphing coming up next, you're going to be given something with x and y, and you're going to have to plug in your own numbers. So I'm going to zoom back out just a little bit, and we'll go out to there, and that should give us enough so we can see it a little bit clearer. So here's what we've got. We've got y and x, so we've got 2 letters. Now you remember back in grade 5 and 6, you guys had to do these coordinate planes. It's almost like playing a game of Battleship, where you had to call out two numbers or a letter and a number, B52. So you looked at B on one side and you looked at 52 on the top, and then you matched them up in order to see if you could sink someone's battleship. What you're really trying to do here is come up with your own values and then plug it into this chart. Going left to right is called the x value. Okay? So if it's positive, you go this way. If it's negative, you go that way first. So you always go sideways first for x. For the y value on this graph, it's the line going up and down. So if your answer, or y, will end up being, say, 3, then you're going to end up with your y value of 3. So you're going to end up with two things. You're going to have an x value separated by a comma and a y value. So I could start with x. Let's say x was 2, and I plug 2 into my formula here. So if I put 2 in for x, 2 times 2 is 4. Take away 5 is going to leave me with negative 1 will be my answer. So I will plot this now, and I'll start with my x. So you always start from the middle. And you say, okay, x is positive 2, so I go over 2, and y is negative 1, so I go down 1 to negative 1. And there's my first point plotted right there. Okay? But how do you know which numbers to use? Generally, whenever you're given an equation and you're asked to graph it, the easiest way to do it is just simply make your graph like this, put x on one side, put y on the other. The x is your input, or the numbers you're choosing, and the y will be your answer, or your output. So we'll start with negative 2, negative 1, 0, and then we'll go with positive 1. I'll put the plus sign there, although you don't really need it. You know it's positive, even if it was just written 1. Usually we pick a couple numbers below 0 and a couple above. So let's start with the first one. Let's plug in negative 2 for x. So our equation, which is y equals 2x, take away 5, I'm going to plug in negative 2, because that's my first one. So let's do that. Y equals 2 times negative 2, and then take away 5, of course. Now let's keep going and keep solving. So y still equals, well, 2 times 2 is 4. But since it's a positive and a negative, it's negative 4. Take away 5. So it's going to become even more negative. So negative 4 take away 5 equals negative 9. So our answer here is negative 9 for y. So when x equals negative 2, y equals negative 9. Now let's try putting x in as negative 1. So I'm going to go down, use the exact same equation. I'll rewrite it again down here. So remember our equation? It is y equals 2x subtract 5. Now, of course, I'll put in my negative 1. So y equals 2 times negative 1, take away 5 more. So 2 times 1 is 2. Since it's a negative, it's going to be negative 2, take away 5 more, and my answer for y is negative 7. So when x is minus 1, y will be minus 7. I'm going to do one more because 0 is really easy to plug into any formula. If we put 0 into here for x, it's going to be 2 times 0. Well, 2 times nothing is still nothing. Take away 5 from nothing, and we're going to be minus 5. So you notice the pattern that's happening. You can look at your first one here is going up by 2 because it's becoming a little bit more positive or a little less negative, whatever way you want to look at it. So in this case, it's going up by 2. And again, it's going up by 2 when you go from this one to this one. So really, we could pretty much fill in the next two numbers without having to work it out. So let's add 2 more on to minus 5, and that'll be minus 3. And then the next one, when we add 2 more, it'll be minus 1. So it's a little trick to solving the rest of them. I like to do 3 numbers because you can see if you made an error in one of them. If you do 3 of them, you can really see. And if you get the pattern the same, you know you're right. So there's our coordinates. So let's start with x at minus 2. So there's minus 2, and y is minus 9. And of course, I don't have enough space here. I got minus 6, so I'd have to go down 3 more. So that's minus 6, minus 7, minus 8, minus 9. So I'd put my dot right there. Let's do another one. Minus 1, minus 7. So we start there in the middle and go over negative 1 for x and go down negative 7 for y, which will be about right there. Again, your graph on a test will be complete or will have enough. Now I'm going to put in 0 and negative 5. So I'm starting at x and I'm going to go over 0. Well, that's easy for x. I just don't move. And then I go down 5 because I'm going to negative 5. I'll plot another one. It's going to be positive 1 and negative 3. So I'm going to go over positive 1 and down negative 3. And finally, positive 2. So I'm going to go over 2, and then I'm going to go down 1. And as you can see, if I were to draw a straight line, providing I had done this pretty accurately, you notice all of it should be in a straight line, because this is a formula for a line. So if it's not all in a straight line, you also know that your answer must have been wrong. Let's try one more. Here we have negative 6x plus 5. For this one, you again draw your table like this. You put in your x on one side and your y on the other, and then you give your minus 2, minus 1, and 0, 1, and 2. Now, do we have to pick those 5 numbers? It's not totally. You could have picked 1, 2, 3, 4, 5. But you do have to make sure that all the numbers are in order. Okay? In this case, they're going up by 1. So if you had to pick 1, 2, 3, 4, 5, it'll still work. So the only thing you have left to do is plug in minus 2 into your equation right here for x, and then see what you get. So if I put minus 2 in here, it's going to be negative 2 times negative 6, which is positive 12, plus 5 more is positive 17. Now, right away you can see there's no way to graph it on this. You would need some graph paper, and you would have to make your own coordinate grid, because negative 2 and positive 17 would be way up here somewhere. Okay? So that's not a very good numbers to choose, these ones right here. The ones you will be given, of course, will be much easier to choose from, and you just go ahead and draw your table with x and y each time, and then put your numbers there and just plug them in. And once you get 3 of them done, you don't really have to do the rest. You can just see the pattern that's going up here and keep jumping like that. So I hope this has been helpful for you, and if there are any questions or any problems and you need some help with it, feel free to email me at mredison@hotmail.com. And of course, nothing's coming out on the computer, so I'll put it here. So it'll be Mr. Edison. My goodness, shocking. I'll try that one more time. Okay. So, Mr. Edison at hotmail.com. And that would be the easiest way to drop me a line. And if you have any specific questions, I can send you a little tiny mini tutorial to help you out.